Hello, Flat Earth researchers, debaters, and debunkers. Okay, I'm going back to basics with this one, looking at the horizon again. I just feel there's a need to do it, and then it's a video to refer to whenever anyone asks me about it, because I'm fed up with explaining about it. So what we've got here is the kind of view you might have looking out at the sea. Obviously this is way off scale. This ship over here should be far off in the distance and reaching the convergence line, which if you study horizons you will have seen this translucent light bending line actually sitting on top of the horizon line there. Okay, sometimes it's very, very thin. It depends on the weather conditions a lot, and sometimes it's quite pronounced. But we do have that every time, and that's why we see the sun sinking down and kind of spreading out. The light kind of spreads out in this area here as it reaches a convergence point. And again, depending on the conditions, sometimes you'll see the sun kind of appear to get squished into this, and it never actually reaches the surface there, the actual horizon line. It just gets squished and fades out in the convergence line. So as we know, the sun appears to sink towards the horizon as it gets further away, just like any other object that's traveling away from us at a consistent altitude above the surface, and that just continues onwards. But when the sun gets far enough away, not necessarily being too small to be seen at that point, it's still rather large, but as it hits the convergence line, this is where we get distortion, and if you like you can refer to it as refraction, I suppose, but basically the sun disappears into this convergence line. It never actually goes down below the horizon there, as far as I can tell. Okay, so that's always there, and that's where the sky and the sea or the ground meet. And you can see the same thing happening to the ship over here. It's when it hits that convergence line, it all gets distorted. So we can effectively we can still see the ship, but it just gets distorted. And obviously, as it gets further away, then it gets smaller and smaller, and or appears smaller and smaller, and eventually is so small that it is completely swallowed up in this convergence line. Okay. And what we see down here is lines showing how, as we look up towards the horizon, the area of the surface area that we can see gets more and more condensed. In fact, you may be able to tell here that, for example, the ship from our perspective is not actually on or behind the horizon. The horizon extends just a little bit beyond it. The idea here is that with these lines is showing that when we look at the surface, we can see all of the surface of the sea or the ground that's ahead of us up to the horizon line. But as, especially with a low, if we are down near the ground, looking out from a normal height of, say, 6 foot tall person, looking out, the more distant surface becomes more condensed, and so you need a shorter space to see a greater distance. And what would happen as you rise up, if you elevated and gave yourself a view from maybe, say, 100 meters or so, maybe even less, 50 meters, then all this condensed surface would kind of spread out. These lines would widen out a bit more, okay, and so you just get a longer angle towards the horizon. So that's what I wanted to demonstrate on this particular image. So if we just take a side view of a similar situation where we can see the observer on the bank there looking out to the sun as it sets and sinks into the horizon or convergence line, okay, and we have the apparent path of the sun giving us this perspective. The sun appears to sink down towards the horizon as it travels away from us. So here we've got the sun just as it's hitting the horizon or convergence line. So this is where the bottom half of the sun would start to get swallowed up. So this point here represents the extent of our vision, the limit of our vision as we can see across the sea. And further over here we can see how the sun would, while it's shrinking or appearing to shrink as it gets further away, of course it is sinking further and further into this convergence line and eventually getting swallowed up by it. Okay, so that's how you get a sunset. That's how eventually the light from here maybe creating a sphere of light above it, which we can see. We can still, that's why we get a glow at sunset. We can still see, but we can't see the source of the light anymore. But the light being emitted by the sun into the sky can still be visible if it's within our field of view. So let's have a little bit of a more detailed look at what happens in our prism eyes. Okay, so here's a little bit of a more complex illustration for what's happening when we look at a sunset. Let's just start at the top here, and first we have the sun here and represented getting further away from us here and here, and it's this is representing the actual height and path of the sun. So above the flat Earth, the sun is said to maintain a fairly constant altitude above the Earth as it does its circle, and this is what would actually be happening with the sun. And so what we have here, just as we saw in the footage just now, we have a cloud in front of us and the sun further away, but we could see from the parallel shadow, and I mean parallel to to the surface and going out in a straight line. The shadow wasn't angling up or down. Okay, so that would indicate that the sun and the cloud are on a similar plane, at a similar height to each other, which is very curious. And down here what we have is this line which represents the perspective of our vision, how our eyes actually interpret this whole scene here. So here we have the clouds, or the cloud and its shadow represented here, and this would be almost like looking down the base of a glass triangle, pyramid or prism, and we are looking down towards the cone. So the cone end, or the tip of it, is where the convergence point or the convergence line and the horizon appear, right in the middle there, always at eye level. Okay, so whether we go high or low, our eyes will create this convergence point at eye level, bringing the sky downwards into the middle and bringing the surface upwards. So with the objects in the sky, like the sun represented here as the way we see it sinking towards the horizon, objects appear to drop and shrink. Okay, anything traveling away from you is going to shrink in apparent size, as well as eventually fade out and drop to the horizon. And here we have the same thing happening from the surface. Here is our actual surface going off in a straight line, and objects appear to rise and shrink as they go towards the horizon on the surface, which is actually here. Okay. One interesting thing to think about, okay, is that the waves cut off the bottom of the boat. So of course we've got waves all along here, but the waves that we see immediately in front of us don't have to be that big necessarily, but they will appear bigger than the waves beyond it. Okay, so remembering our 3D perspective when we are looking out, the objects right close to us are very large in our vision, and the further away those objects are, even if they are a similar height, they will appear smaller and smaller as we look at them getting more distant. Okay, so this is one thing that causes the horizon here, is eventually you get to a point where even if you've got a small bump in front of you, whether it's a wave or a hill or just the land in general, there is going to be a point where the land beyond that becomes too small and insignificant. Even a mountain a long way off will not appear tall enough to reach above the horizon, because it's just become too small for us to actually make out. Okay, and that should help you see what's actually happening with the sun as it comes down. The bottom of the sun gets cut off as it reaches this convergence point. Now here we can see the ship here has gone beyond the convergence point, but the mast is still sticking up high. So we would still see the mast in our vision, but right here, all this grey area here is the blind spot beyond the convergence point. Okay, so from this point here, even if the sun is shining on this object, that light reflected from the boat is not getting back to us past this convergence point. It's just too far away, and of course, as we said, around here everything is getting condensed into the horizon. And one other consideration is that people may have difficulty thinking about is, if the sun is coming down from the sky and the bottom of the sun is getting cut off, then we also have the bottom of the ship getting cut off at the convergence point. How come they both behave in the same way? Well, the ship is actually on the surface. So what we see of the ship is actually filling up part of the sky. So when the ship and the sun come down to this convergence point or line, then both the bottom of the sun and the bottom of the ship are going to disappear first, because the ship is actually taking up part of the sky. Yeah, so they eventually appear to meet the same position above the horizon. So the bottoms of those objects both then disappear into the convergence point. So let's just go back and have a look at one of two sunsets I filmed recently. So this is a combination of three photographs or snapshots taken from the footage where I was zoomed in to the horizon as the sun set. So the camera wasn't moved at all, or the zoom wasn't played with at all in this scenario, but obviously the light is a little bit different, which you can see in the layering I've done here. But basically, just to show that I traced circles around the edge of the sun in these three snapshots, and as it got lower towards the horizon, we can see that it went from the top one showing 306 by 282 pixels down to 301 by 265 pixels, and then we have the yellow one at the bottom, 295 by 251 pixels. And I think there's a bit of a more of a dramatic drop in the vertical diameter there, because it's starting to get squished into the horizon, so it's slightly oblate, as it were. And this is taken, more snapshots taken from filming of another sunset. And we can see here again, I used lines this time, just drew a line from the across the diameter of the sun and measured the pixels, and up above there we have 302 pixels, and then it goes down to 297 pixels, and as it's hitting the convergence line, 290 pixels. I did try and work out some of the speeds and distances that might be involved here, but either way we can see now that the sun does shrink as it heads towards the horizon, bearing in mind that even though the horizon appears to cut off the sun, it's going into that convergence line just above the horizon, and the horizon, the foreground, the surface is created in our vision. So there's a definite or a finite limit to how far the foreground will extend, and then it must cut off at some point. Okay, enjoy some more of these sunsets with some accompanying music. Relax and keep it flat. Thank you.